Okay, great. Sequences. Here we go. You're going to relive your years in Algebra 2, okay? Arithmetic sequence. Boy, I'm going to have to go lickety-split here. There's not a rally today, is there? OMG, there's no rally, is there? Okay, thank God. Okay, great. So we got arithmetic sequence, like 5, 8, 11, 14, 17. Okay, that's an arithmetic sequence. You tell me, why is that called arithmetic? Yeah, you're adding the same number each and every time. Okay, so that same number that you're adding each time is called the common difference. Okay, and so now I need to take you to two separate and distinct universes. Okay, this sequence is called an indexed list. That is, there's a first term, a second term, a third term, etc. But also, you can think of this as the 0th term, first term, second term, third term. You see? And I need to prepare you for both eventualities. Okay? So suppose my indexing is to say that's the 0th term, that's the first term, that's the second term, that's the third term, that's the fourth term, etc. Then I can get an expression for a sub n, which is the nth term. Okay, that's what this is. The real way to write this would be to do this. Would be to say a sub n equals, and then when you have curly brackets and a bunch of stuff inside curly brackets, that just means it's a list. It's a list of terms. You know, I mean, when I go shopping, I go, well, I'm going to get bread, and I'm going to get milk, and I'm going to get butter. Okay, I do that because I know in between the curly brackets, it's just a list. You know, so here's a list of numbers, and this list of numbers is indexed, it's ordered, okay? And so I'm going to get an expression for a sub n, okay? And in this case, what's my expression for a sub n going to be? I wonder if anyone can just tell me.
3n.
Yeah, beautiful, 3n plus 5, or 5 plus 3n. Great, and there's an easy way to check. Stick in a 0, do I get 5? Stick in a 1, do I get 8? Stick in a 2, do I get 11? Okay, so generally, a sub n is going to equal dn plus a naught if the first term is n equals 0. Then that's your formula, and it's actually an incredibly simple formula. I love it when the first term is 0. But sometimes you're going to have a situation where your first term is 1. Where you're going to go, no, I don't want that. I want the first term to be the first term, and the second term, and the third term, and the fifth, you know what I mean? Why have a 0th term? That makes no sense to me. So if your n is going to be 1, now a sub n is going to have a different formula. What's the formula for a sub n going to be now?
3n plus 2.
How many people thinking 3n plus 2? Okay, that's beautiful. If you just use your cleverness, that's good enough. This isn't Algebra 2. I'm not going to give you crazy problems where you have to give me the formula and plug into the right formula. Just use your cleverness. Some of you may remember in Algebra 2 land, you actually learned this formula. You know, you actually learned to do it like this, which I absolutely abhor. You know, I think that's so dumb. And so the nth term, if your first term is 1, ends up being d times n minus 1 plus a1. You see what I mean? Does anyone in here remember learning it this way, where you had an n minus? Okay, yeah, well, I hate it. So just use your cleverness. The important thing you calculus kids need to know is just whatever the common difference is, that's the guy being multiplied by d. Whatever the common difference is, you're multiplying it by d, and then just use your cleverness to figure out the next one. Okay, so I'm going to ask you to do this now without using formulas. Just use your cleverness. What if I gave you this? 12, comma, 7, comma, 2, comma, negative 3, comma, dot, dot, dot. And that's my a sub n. Okay, could you get me an expression for a sub n? And I'd like you to give me an expression where it starts with n equals 0, and give me an expression where it starts with n equal 1. Please do both right now. I'll give you 30 seconds. And I just want you to use your cleverness. Don't be plugging into any crazy formulas. Ah. All right. So someone tell me, what'd you get for the first guy?
12 minus 5n.
Good. 12, how many people got 12 minus 5n or negative 5n plus 12? Okay, yay. And there's always a way to check, right? Stick in a 0, do I get 12? Stick in a 1, do I get 7? And how about this guy?
17 minus 5n.
Good. And I really prefer this. I absolutely hate this form. You know, I way prefer this. Just use your cleverness. You know it's going to be negative 5 times n because your d is negative 5. And then just use your cleverness to figure out that guy. Okay, hey, that's arithmetic sequences. Now it's time to do geometric sequences.
Yay. Did we already do that like a few days ago?
Yeah, we did. We absolutely did.
Oh, okay.
Okay, then here we go. How about this? 3, 6, 12, 24, dot, dot, dot. That's my sequence now. Okay? What do you notice is true about this sequence?
They multiplied by 2.
Thank you very much, Daniel. You're multiplying each and every successive term by 2, so that 2 is my common ratio. Okay? So let's say I start with n equals 0. Alrighty? Someone give me an expression for a sub n. What do you think? Quick, Kylie. No, it's all going to be multiplied. 2 to the n times what? Okay, well, we'll stop there. Yes, Abigail? 3 times 2 to the n. 3 times 2 to the n, right? Because when n is 0, I get 3. When n is 1, I get 2 times 3, which is 6. When n is 2, I get 4 times 3, which is 12, etc. And so generally, when n equals 0, it's going to be a naught r to the n. And again, I like n equaling 0. The problem is sometimes you're not going to get n equals 0. Sometimes you get n equaling 1. Okay? So now it's time to get our nth term when n equal 1. But here's the weird proviso. We like to have this multiplying guy, not the guy being taken to a power, which is always my r. We like this multiplying guy to always be the first term. So it's still going to be 3, but now it's going to be 2 to what power?
N minus 1.
Yeah, n minus 1. If I'm starting with n equal 1, then it's going to be 2 to the n minus 1 power. And there's going to be times when this is a more convenient way to express it. So you're going to be stuck having to do that n minus 1 stuff. You know, so generally a sub n equals a1 r to the n minus 1 power. Okay.
Mr. Zena,
Yes.
how would you write it so that you don't have to write the n minus 1?
Then you'd have to have some different number there, like 3 halves.
Oh, okay.
Yeah, and we just don't like to do that. Whatever the first term is, we really like that to be the multiplier.
Oh, I understand.
You know, but there's going to be some times where it's just more convenient to start with n equal 1, and if that's the case, then you're stuck having to do that. So here, let me give you guys one. Here we go. 36, comma, negative 12, comma, 4, comma, negative 4/3, comma, dot, dot, dot. Go ahead and give me a sub n when I'm starting with n equals 0, and a sub n when I'm starting with n equal 1. Good luck, you guys. Good luck. I'll give you a hint. For the n equals 0, use that for the n equal 1. Okay, thumbs up. What did you get as your common ratio? Yeah, negative 1/3. Good for you. And the first term is 36. So you know you're always going to start with that 36, whether you n equals 0 it or n equal 1 it. But here it's going to be a negative 1/3 to the n power, and here it's going to be negative 1/3 to the n minus 1 power. How many people got that right? Okay, yay, everybody. Okay, then the next thing, what's that?
Is it okay if we put the -1 to n, like instead of -1?
Oh yeah, when we learn about alternating series, I'm actually going to talk about that. So this would be 36 times -1 to the n minus 1 power times 1/3 to the n minus 1 power. But it still has to be, if n is equaling 1, it still has to be the n minus 1 power, because you still need that first term to be positive, you know. Okay, well then the next thing I'm going to talk about is convergence and divergence of sequences. And this is going to take 60 seconds. Okay, here. You know, unfortunately, you guys, I'm stuck. I'm probably going to have to post that stupid thing online, even though I know everyone prefers hard copy. But I'll give you a hard copy tomorrow of it and everything else we're going to do.
Tomorrow's Saturday.
Oh, yeah. Tomorrow we're going to Pasadena. Who's going to Pasadena tomorrow? Yay. But you're not going with us, though. Andrew, you're not.
Oh, no, I'm not. I didn't raise my hand.
Oh, okay. But Leilani and Justin. Good.
What about
I mean, not Justin. Yeah, Justin. I was almost going to call you Jacob. No, you're not Justin, you're Jacob. Wait, no, you are Justin. You're the original. You're not the new guy. Okay, well, anyway, it's going to be great fun. I love our Pasadena trip. It's just so fun for me.
I like
Okay.
going to visit the turtles.
What's that?
I like going to visit the turtles.
Absolutely. Yeah, absolutely. Happy little turtles. Okay, here's another thing. When does a sequence converge or diverge? Okay? And I need to answer that question now. A sequence converges when the infinitieth term is a specific finite number. A sequence converges when the infinitieth term is a specific finite number. So I'm going to give you some sequences and ask you if they converge or not. Here comes the first one. A sub n equals 4 times 1/2 to the n power, which I would write this out as 4, and I'm going to have n equaling 0 for every one of these guys. 4 plus 2, 4, comma, 2, comma, 1, comma, 1/2, comma, 1/4, comma, blah, blah, blah. Tell me, does this guy converge or diverge?
Converge.
How many people say it converges? Yay, and what does it converge to? Wait, what, 8?
Yeah.
No, you're not adding it, you're looking at the terms themselves. Yeah, because converges to 0. The limit as n approaches infinity of a sub n is equal to 0. The infinitieth term is 0. Yeah, no, granted, I agree, even the sum of them even adds up to something, it adds up to 8. But I'm asking for the sequence itself, and the sequence converges to 0. Here, let me give you another one. What if I gave you a sub n equaled n over n plus 1? So that this ends up being a 0 plus, what is that, 1/2 plus 2, not plus. Now you got me thinking in terms of series. I blame you guys. That's, or rather, comma 3/4, comma 4/5, comma 5/6, comma dot, 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 dot. Okay, tell me, does this sequence converge or diverge? That is, what is the infinitieth term? Not the sum of the terms, but just the infinitieth term.
1.
Good, the infinitieth term is 1. So since the limit as n approaches infinity of a sub n equals 1, It converges. So both of these guys converge. Now, tomorrow we're going to learn about series, and this series, the sum of the terms converges. You guys got it, it was 8. Do the sum of these terms converge? If I added an infinite number of them, would they converge? Heck no, because when I get to infinity, I'm just adding 1 plus 1 plus 1 plus 1 plus 1, and so I'm not going to get, a convergent series, but the sequence converges. Here, let me give you one last one. A sub n equals any arithmetic sequence. Any arithmetic sequence I can think of in the whole wide world, okay? You tell me, converge or diverge? Yeah, diverge, right? Because any that you think of, you just keep adding or subtracting the same number over and over and over again. You're either going to end up in positive infinity or negative infinity. So this diverges. That'll be a 1/3, 2/3, 3/3, 4/3, 5/3. And go forever and ever and get bigger and bigger. Not very quickly, but you still get bigger and bigger.
No, I was thinking of geometric terms.
Oh, well, geometric's a different story.
Yeah.
Okay, here's the last thing I want to tell you, and thank you for your patience. And like I said, I'll post that on School Loop. It's an incredibly easy assignment, so don't worry, it'll be fine. Quadratic sequence. And I'm hoping we can get this in our last few minutes. Quadratic sequence. What if I gave you this? 5, 7, 10, 14, 19, dot, dot, dot. Can you guys guess what the next term is?
25.
How'd you get 25?
Because it's plus 2 plus 3.
Good. Did you guys notice what name do I give, not to the terms themselves, but to what's happening to each term, how much I'm adding to each term? What kind of sequences are those adding numbers becoming? What kind of sequence is that? 2, 3, 4, 5, 6? Arithmetic. When the differences between the terms form an arithmetic sequence, then this is a quadratic sequence. Okay? When differences are or form an arithmetic sequence, your sequence is quadratic. And if the bell rings, I'm going to hold you here just another minute. I'm going to hold you captive for another minute. That means a sub n equals a n squared plus b n plus c. And I'm going to start all of these at n equals 0. And I'm going to demonstrate here how you would get big A, big B, and big C. Okay? First of all, when n equals 0, a sub n equals a times 0 squared plus b times 0 plus c. And that ends up equaling 5, correct? So I got c equal 5. So with quadratic sequence, your constant term is always your first term. That never changes. Let's get the next one. Here, a sub 1 equals a times 1 squared plus b times 1 plus 5, which equals 7, which means a plus b equals 2. And then when n equals 2, a sub 2 equals a times 2 squared plus b times 2. Don't leave yet, I'm so sorry. Which means I get 4a plus 2b equals 2. Alrighty? And so now I'm going to solve for a and b, and I can either do subtraction or I can do substitution. I'm going to do subtraction. So I'm going to multiply everything by 2. So I got negative 2a minus 2b equals negative 4. So I get, right? So I get 2 whoops, 2a equals negative 2, or a equals negative 1. A equals negative 1, really? Is that looking correct?
I can't see it.
Negative 2. I gotta add them. Well, anyway,
Oh, Mr.
so,
Trina.
yes?
You said n2 equals 7, but it's 10.
Oh my God. Okay, thank you. That's what happens when I go too fast. Oh, you're so smart. Thank you, Andrew.
It was Kimberly.
Thank you, Kimberly. Kimberly, the gum chewer? Thank you, Kimberly.
She got a lot of gumption.
So now this is 1. My goodness. So that's a half. So a equals a half. So b equals 3 halves. So my guy here, or I'll just put it up here, my a sub n is 1/2 n squared plus 3 halves n plus 5, and that's going to get you there. That's my quadratic sequence. So that's it. I just want you to be aware how to get a quadratic sequence. And good luck on the thingy, and I'll put on school loop probably during my prep period, during fifth period. Don't turn it off yet, because we want to see. There's Fatima. Let's see what Fatima looks like. There's she. Oh, she's hiding her head. Here's my class. Yay, my happy class. Okay.